It stopped recording. There we go. So when it's direct variation, what do you set up? Proportions or products? Proportions. Okay, so we're going to set up proportions here. So, and honestly, it doesn't really matter which number goes on top and which one goes on bottom because the relationship with proportions is the same. What would you do? What over what? Okay, so if we do G over M, then where does the D go? On the bottom, miles across from miles, right? So what we're solving for, just call it X. And then you can either just multiply by D on both sides right now, or you could cross multiply right now. I will cross multiply just because I feel like that's what majority of people end up doing. I think multiplying by D is easier. It's quicker. But if we cross multiply, you get mx equals gd, and then we would just divide by m. So x is equal to gd divided by m. Okay, dg divided by m, same thing. Doesn't matter the order of those top two. Number 2, a weight of 120 pounds is placed 5 feet from the fulcrum of a lever. How far from the fulcrum must a 100-pound weight be placed in order to balance? Do you know how a lever works? This was, what grade? 4th grade science? We had to set up a lever for my son last year. Super fun. But basically we're saying if the weight is more, the distance away is going to be less. Right? So as one goes up, the other one goes down, or vice versa with a lever. So that's what kind of variation? That's inverse. And remember, for inverse, we're going to set up products. So this is going to be 120 times 5 equals 100 times whatever we're solving for. And then you'll just solve that. So divide by 100. 120 times 5 divided by 100, you get 6 feet. Okay, so it would have to be 6 feet away for 100 pounds. All right, number 3. Tell me what you should do first. Take out the 5, sure. So if we factor out a 5 here, that would be a plus 1. I'm just going to cross that out and pretend it's sitting in the right spot. What else can you do? Factor out a 10. And you're left with a plus 1. Okay. Now what? You could multiply across. I wouldn't, but you totally can, and a lot of people like to. If you multiply across, you would have 50 times a plus 1 over 5a times a plus 1. So you could do that if you prefer that. I typically just start slashing right away. What's your preference? I would like to do it the way you would like to do it. Slash first? Okay. So a and a will reduce to 1. 5 and 5 will reduce to 1. A plus 1 and a plus 1 will also 1 out. What are you left with? 10. Okay. All right, number 4 looks really fancy because there's just a lot going on there, but it's really just a lot of factoring. And you guys are good at factoring. What's your numerator going to factor to? X plus 2 times x minus 2 over, if you do star method here, what can you multiply to get 9 that you can add to get 6? 3 and 3. Okay, what's your other numerator going to be? X plus 3, x minus 3. And then this one, what can you multiply to get 4 that you can add to get 4? 2 and 2, x plus 2, x plus 2. Okay, so now from here, I mean, you can pretty much just treat this as one big division bar, right? A numerator and a denominator. X plus 2 and x plus 2, 1 out. X plus 3 and x plus 3, 1 out. There's nothing else that one's out here. So it's going to be x minus 2 times x minus 3 over x plus 3 times x plus 2. And that'll be your answer. All right, look at number 5. What do you do with division? Flip it and multiply, right? Flip it and multiply. So I'm just going to rewrite it. 5xy squared over 4xy times, and now flip it over, 20y squared over 15xy. Again, I tend to just start slashing. If you want to multiply across right now, you can multiply across. Sometimes it does seem a little easier to multiply across just because of the variables and your exponents. So I'll show you both ways. If you multiplied across right now, 20 times 5 is 100. You have x, and you have y to what power? The fourth, okay? On bottom, 4 times 15 is 60. X squared, y squared. Okay, so you could do that, and maybe that's a little simpler with your exponents. That's fine if you would prefer to do it that way. I would probably do 5 and 15 is 1 and 3. 20 and 4 is 5 and 1. X over x is going to be 1. Y to the second over y to the first is going to make this y go away. And now this is just going to be y. Okay. This one, y to the second over y to the first, is going to make this y go away. And we're just going to be left with a y right there. And I think that's it. So you have 1 times y times 5 times y. So that's 5 times y squared. And then it's 1, 3, and x. So that would be 3x. And you get that. Like I said, you could just reduce this. 100 over 60 would reduce to 5 over 3. You would have an x on bottom and a y squared on top. So that's up to you, which way you like better. Yeah? Whenever you're dividing, you flip it and you multiply. Once I flipped it, then I can start reducing. Yeah, like 5 and 15, both of those are divisible by 5, so 1 over 3. Yeah. Yeah.
How did you do crossing out the variables again? Simplify.
Yeah, so if you have 5, do you want me to do it here, or you want me to do it with the way I first did it?
Like the second one.
This one?
No, the first one.
Okay, yeah, sorry, I know, the one I did second, or the one that is second. So 5xy squared, hi Julia, over 4xy times 20y squared over 15xy. Okay, so if I'm going to get rid of the variables, x over x is just 1. So those are both going to go away, right? This is gone, that's gone. Y to the second over y to the first, you subtract. So 2 minus 1 is 1. So that's just going to be a y on top. X isn't going to simplify at all. And then this one, y to the second over y, if I simplify that, you know what? The other way you could just do it right now is you could cancel this y with that y, and you're left with y squared. That works too. But if you prefer the ones that are over top of each other, you would take this is going to simplify to just y, right? So now y times y is y squared for that. Is that good?
Yeah.
Okay. Okay, so that is 5. Okay, now here's what I want you to notice. Everything we've done so far has been multiplication or division, right? Okay. Do you need a common denominator with multiplication and division? No. Okay, now we're moving on to addition and subtraction. You have to have a common denominator. Okay, so just keep that in mind. When you see a problem, if there's a multiplication or division, don't worry about a common denominator. If it's addition and subtraction, then you need a common denominator. So if you look at this problem, what's our common denominator? It's 9. So this one you can just say is x minus 4x over 9. X minus 4x is a negative 3x over 9. And that simplifies further. Negative 3 over 9 is negative 1 over 3, right? So this is basically a negative x over 9. You can put the negative with the x. You can put the negative out in front. I'm not going to be picky on where you drop that negative, but that would be your setup. Oh, sorry, 3. My bad. I didn't reduce. I was so focused on the negative. It's a 3. Negative 3 over 9 is negative 1 over 3. So far, so good? Okay, number 7. Now we're adding. Is this your quiz one? Or did I just do this so many times that I feel like it's familiar?
It looks like it.
I think this was your, oh no, it was different. Okay, anyway, for this one, what would your common denominator be? 10x squared y squared. Okay, so that's your common denominator. What does that mean you have to multiply by on the left? 2y over 2y. Okay, so up top you get 12y. Do you need me to write these separately still before we add them, or can I write the whole numerator up top? Is that okay? I don't know what makes the most sense to everyone, but I feel like this just simplifies life a little. 2y times 6 is 12y, right? I know this is my common denominator, so I'm just going to put it one time. We are adding to that whatever we need to do over here. What do I need to multiply this by to get 10x squared y squared? X over x. Okay, so then it's plus 5x, still over 10x squared plus y squared. Is there anything you can simplify there? Mm-mm. If all of your numbers were divisible by the same thing, like all of them were divisible by 2 or all of them were divisible by 5, then you could, but we can't. So you just leave it like that, and that will be your answer. Okay. All right, number 8. Okay, this one, we're adding. What do we got to do? Really, you just have to add the numerators together. There is some factoring that makes sense to do here. If I take out, what is your denominator going to be if you factor it? 3x plus 1 and 3x minus 1, right? So if I simplify this, 3x plus 1, 3x minus 1, okay? Simplify this now. 6x plus 3x is 9x. Negative 4 plus 1 is a negative 3. What can you do from there? Do you see it? Factor out a 3 on top, right? So if I factor out a 3, I have 3x minus 1, and then on bottom 3x plus 1 times 3x minus 1. So these will 1 out, and what you're left with is 3 over 3x plus 1. Does that make sense? All Always factor it out if you can. All right, last one of these, and then we have some book questions to address. All right, number 9. What are we gonna do? You can't cross multiply because we're not setting them equal, right? If they were equal, if this was an equal sign, then yes, cross multiply. But we're subtracting. What do you need with subtraction? Common denominator. So if you treat this like 3 over 1, right now, this x squared plus 5 is not a difference of squares, right? So it's not like you can break that into x plus something, x minus something. So instead, that's just going to be our common denominator, x squared plus 5, not 15, sorry, x squared plus 5. So what are we going to multiply the 3 by? X squared plus 5 over x squared plus 5, okay? So when we simplify that then, we get, I'm just going to write it like this first, so you see what I'm doing. Right? I'm just subtracting those. I already have my denominator on the right, so you don't need to multiply the right side by anything. And now you can distribute. So that's 3x squared plus 15 minus 1 over x squared plus 5. Okay? Which means it is 3x squared plus 14 over x squared plus 5. It's really tempting right there to go, oh, x squared over x squared. I can slash that away. But this is an expression, and this is an expression. So if you can't take an x squared out of everything, you can't take it out of those first two. Okay? I subtracted these, 15 minus 1. So that's as far as you can go. Okay? Is it 9 o'clock today or 9:05? 9. Ugh. Okay. I don't think we're going to do all of these. We're going to do some of it. And you don't have to finish it. If you want to finish it, it's not a terrible idea just to get you ready for the test. But I'm not going to make you finish it because you have a review worksheet to do for homework for the weekend that does a lot of this too. So let's take a look at this. If we are talking variation and it says y varies inversely with x, what is that?
Inverse.
How do you write it?
XK.
Over x, right? Inversely is k divided by x, okay? So this would be your setup. Then to solve it, you would just drop these numbers in. So -8 equals k over 2, multiply by 2. So your k value is -16. So when I ask you to write a specific equation, what are you going to do? -16 over x. Yes, that would be your specific equation. Okay. I'm not going to do the rest of these, but it says z varies jointly. What does that mean? Z equals k times x times y, okay? This one says z varies directly with x, so z equals k times x, and inversely, so divide, with the product, we're multiplying r squared and y. Okay? If you just follow their wording and put a symbol or a letter or whatever with a word, it's pretty true to the order that they come in. Okay. I'm going to stop there.